So let us start off with electric potential due to a uniform ring. So we have a ring, let us say, of radius capital R. So what should I take my element as?
Is that uniform disk?
Sorry, uniform disk. So what should my element be for a disk?
Ring, sir.
Ring, right? So let's take this radius of the disk to be capital R. Then the element that I will take is a small ring at a radius of R having a width dr. Correct?
Yes, sir.
What is my next thing that I have to do?
That is forming 2 pi r and also like moving r radius. And dr, it will be 2 pi r.
What will be 2 pi r? Yeah. So next thing I will,
dA.
we can write dA is equal to dA, which is the area of this shaded region, correct?
Yes, sir.
Is 2 pi r dr. Next, because it is this, let us say the charge per unit area, which is sigma.
dq upon dA.
So sigma is equal to dq upon dA. Therefore,
That equal.
dq is
Okay.
dq is equal to sigma times whatever this dA is there, we'll substitute. Okay, what is my next step? First of all,
equal to total q upon total area.
Which is also total q upon total area, which is pi into capital R square, right?
Yes, sir.
First of all, the question is, find the electric potential due to the disk at a distance of x above the center, right?
Yes, sir.
Perpendicular to the plane of disk. So let us say this point is some A. So the question is, what is the potential at A due to disk, right?
Yes, sir.
What should be my next step?
Then we take components of it.
Components will come when there is a vector.
Okay, yes, sir.
The next step is, I will write why did I think about the question at this stage?
You join A to the dr. Then we write the distance of it.
And we write the distance of it. So I'll draw a separate right angle triangle over here. So this distance is x and this horizontal distance is smaller, right?
Yes, sir.
So my hypotenuse will come out to be under root of x square plus small r square. Fine.
Yes, sir.
So now dVA at point A is equal to, tell me, K dq by
under root of x square plus r square.
X square plus r square. Nice. Next is,
integrated because we need the entire.
Next is we substitute this story over here.
He can do that after. Yes, sir.
Right?
Yes, sir.
So K sigma 2 pi r dr upon square root of x square. Okay, tell me what is my next step.
First integrate.
So next I will write VA is equal to, which is integral of dVA, which is equal to integral of this entire story, right?
Yes, sir.
So I can take the constants outside. Yeah,
Yes, sir.
we can take the
K
const.
sigma 2 pi.
Yeah, tell me.
K sigma 2 pi.
Those constants. Yeah.
They're not constant. Integration of r dr upon
What is my next step?
of x square plus r square.
By
We
the
can
way,
take x square plus r square as some t square.
by the way, limits is 0 to r.
0 to r.
Okay. Next is we can take x square plus r square is equal to t square. Next,
Differentiate.
what will I get?
Yes. Yes, sir. 2r dr equal to
Good.
2 to cancel. Uh, r dr equal to t dt.
Good. Coming back to here.
Put t dt upon t.
T dt upon t.
That will become
T.
t. Yes, sir.
2 pi k sigma. This will become t.
R. Wait.
Limits.
Yes, sir.
I mean,
Zero.
right now, in terms of t, we did not find the limits, right? So we'll bring
Yes.
it back to our r. Are you understanding what I said?
Yes, sir.
I'll bring it back to my original, which is square root of x square plus small r square, right? And now my limits are from 0 to capital R.
Yes, sir.
Next step. By the way, sigma we can write it off as q by pi r square.
Divide pi r square. Then pi s gone.
Pi is cancelled. So what should I write? 2
2aq by r square into sigma. Wait.
sigma is gone.
Yes, sir.
Upper limit.
X square
Square root of x
square plus capital R square.
minus lower limit.
Oh, x. Sir.
This is the final answer. Clear?
Yes, sir.
Not at all difficult, right?
Yeah.
Hello everyone, welcome to Veracious Academy. My name is Anil Kumar. I am an alumni of IIT Bombay. I have done my BTech from Mechanical Engineering. I have been teaching physics for the past decade for JEE Mains, JEE Advanced, Neet UG and other competitive exams. If you're interested to attend my sessions, please find the contact details in the description below. Let's get started with this lecture. Enjoy the video.
So, no name concept. Simple story. Suppose I have a charge at a point A. Okay.
Yes, sir.
And it is a positive charge. Right? And there is an electric field, uniform, non-uniform. We are not bothered. Literally. Okay. Because what we are studying is not a specific detail and all. We are basically trying to understand a concept from this story. Okay.
Yes, sir.
So there is a uniform electric field everywhere in this region in the horizontal direction. This electric field is due to some external agent. Okay. This electric field is not due to this point charge. Point
Yes.
number one. Okay. So this electric field is existing uniformly everywhere in the horizontal direction, left to right.
Yes, sir.
Now I have placed a charge plus Q.
Yes, sir.
This charge is free to move. What will happen?
There will be attraction or repulsion.
Attraction or repulsion is
There is no other charge.
no other charge. I have placed a point charge which is free to move in an electric field.
Yes, sir.
Uniform or non-uniform, I have placed a point charge in an electric field.
Yes, sir.
It will exert a force. This electric field will apply a force on the point charge,
Yes, sir.
right?
Yes,
The
sir.
definition of field is force per unit charge.
Yes, sir.
So basically, if you look at the force F bar, it will be nothing but this point charge into E bar, correct?
Yes, sir.
This much amount of force will act on that point charge. Fine. In the same direction as that of electric field.
Yes, sir.
Now, because this charge is under a force and it is free to move, so obviously it will move.
Hmm.
So let us say it moved from point A to point B.
Yes, sir.
Obviously, it will move further point B also if you leave it forever, right?
Hmm.
But we are only trying to study a portion of the entire movie.
Yes, sir.
So there is an electric field, uniform or non-uniform. There is an electric field from left to right. In this electric field, I have placed a point charge. This point charge will feel a force due to this electric field in the same direction, correct?
Yes, sir.
Due to that force, there will be motion in the body, correct?
Yes, sir.
So therefore, the point charge will move from A left to right, okay? And let us say that we are trying to study the motion of the body from A to B. Correct?
It will do some work.
Good. So basically, if I will take this vector AB bar as some R bar, we can take it as DR bar also, but I am taking it as R bar. Okay. So like you said just now, there is some kind of a force involved in this, and force due to electrostatic force, right? That F bar.
Yes, sir.
So here I am not doing anything. External agent has no role to play in this.
Hmm.
Some electric field is generated due to whom nobody knows.
Yes, sir.
Somebody placed a point charge. Who placed it? Nobody knows. So we are not. If you remember that story of potential energy, we brought it from infinity to a distance of.
Yes.
In that we brought it. That means an external agent. Role of an external agent is there.
Hmm.
In this story, I am not involving role of an external agent. There is a field, there is a charge, motion. Motion due to whom? Motion due to the electrostatic force.
Yes, sir.
Simple. I have nothing to do with what is happening over here. Everything that is happening over here is automatic.
Yes, sir.
Fine.
Yes, sir.
So obviously work is done by whom?
By that charge plus Q.
Charge is the fellow who is being pushed. Someone else is applying that force. Who is applying that force? Due to the
Yes,
electric field.
Yes, sir.
Due to the electric field. We don't know why this electric field is. Okay.
Yes, sir.
We don't know the source of this electric field. So this force is due to this electric field. That's all that we know. So therefore this work done is due to whom? This electric field.
Yes, sir.
There's only one fellow who is working, and that is this electric field fellow in this entire story. And that
Yes.
work done, I can write it as F bar dot R bar, right?
Yes, sir.
So why I'm mentioning that I'm not doing anything, because if you remember 5 lectures back, we had a work energy, potential energy story
Hmm.
in which there were two people. One is external agent and the other is the electrostatic fellow.
Yes, sir.
Then in that we saw that work done by electrostatic force is negative of change in electrostatic potential energy but positive of change in external potential energy.
Yes, sir.
Right? So there we had two fellows. Here we have no other fellow, only one, that is this electric field. Whatever is happening in the story is happening because of only this electric field. Clear?
Yes, sir.
That's why I'm not mentioning any subscripts anywhere. No confusion. There's only one fellow who is doing the entire thing. That is this electric field fellow. We are not even bothered about what is the source of this electric field. We don't care.
Yes, sir.
Is it clear?
Yes, sir.
So because there is only one fellow, work done is equal to positive of change in potential energy should come or negative?
Negative.
Negative, because the same, when we talk of same fellow's work and potential energy, negative sign will be there. That's what we saw that day, right?
Yes, sir.
So this fellow, I can write it as negative of change in potential energy.
Yes, sir.
Okay, so till now I mentioned that subscript because if I write this directly, people generally get confused. Okay, whose potential energy, whose work done? Recently you taught electrostatic potential energy, external potential energy, all these stories. There is no such story over here. There's only one fellow electric field, and every subscript that we are writing will have the same fellow electric field. That's why I'm not mentioning anything. Okay,
Yes, sir.
great. We have come till here, but we have already defined electrostatic potential as what? Electrostatic potential is equal to potential energy by test charge, right?
Yes, sir.
So I can write U is equal to Q into V.
Yes, sir.
I can substitute it over here.
Yes, sir.
So I will get this as minus of delta. In place of U, I can write it as Q into V.
Yes, sir.
Is this clear?
Yes, sir.
Okay, fine. We are coming closer to two same concept but two expressions involved with it. Okay. Now, force F bar dot R bar, which is work done, I'm rewriting it, okay, is equal to minus, this charge is constant, I can take it outside,
Yes, sir.
Q times of delta V.
Yes, sir.
But F bar itself is equal to Q times of E bar.
The Q is gone.
Good. So Q times of E bar dot R bar, correct?
Yes, sir.
Is it clear? So if we focus only on this, my Q will get cancelled. I can write minus delta V is equal to E bar dot R bar. Correct?
Yes, sir.
This is very important. Okay. I randomly with something I brought it, but it is important. But first let us study the physics of it. Then we will come back again to the mathematics.
Yes, sir.
Somehow we reached here unknowingly, substituting something random stuff and all. Let us first look at the physics of it. Okay.
Yes, sir.
There are 2 points A and B. Obviously, there are 2 potentials VA and VB.
Yes, sir.
System, which is the charge point Q plus Q, point charge. That point charge is automatically going from A to B, correct?
Yes, sir.
And the electric field is from left to right.
Yes, sir.
So, my question is the potential at A greater than B or B greater than A, or are they equal? Is VA greater than VB?
VB is no. VA should be greater than.
So this here I want to remind you, heat energy in heat energy flows from higher temperature to lower temperature.
Yes, sir.
In fluid mechanics, fluids flow from higher pressure to lower pressure. In electrostatics, current, electricity, a positive charge always moves from higher potential to lower potential.
Yes, sir.
In current electricity school, you have already done Ohm's law, V is equal to IR. You said that the current is flowing in this direction because higher potential to lower potential, school stories.
Yes, sir.
Is what we are coming here also in a different way.
Yes, sir.
So, I'll repeat again. Remember, whatever is electrostatic potential for electrostatics is gravitational potential for gravitation chapter, is pressure for fluid mechanics, is temperature for heat.
Yes, sir.
Never forget all these things, okay? Because all these physical quantities are behaving as the prime source due to whatever science is happening behind it. That's why I said potential is very important in general, is because if you see in this chapter you have potential, in capacitors you will have potential, in current electricity you will have potential, and it goes on. And in real life also you will have potential. If you buy a bulb, on that it will be written how many volts and how many watts.
They'll write number of volts, but how does that number of volts be potential of itself?
We will discuss this particular thing, end of current electricity.
HCV, yes, sir.
Huh?
There was a question on HCV, sir.
You send photo, okay?
Yes, sir.
What I am saying is practically when we buy bulb or all out machine, literally any machine that runs on electricity, okay? So if it's a legally sold thing, there has to be parameters written on it: voltage, wattage, amperes, how much current can flow through it. Okay, so these are mentioned. Why these are mentioned and how they are related and blah blah blah, we will discuss at the end of current electricity chapter.
Okay, sir.
What I'm trying to say at this point is that there is a physical quantity in all the chapters which is important and which plays the same role and has different names. In this chapter it's called electrostatic potential. In gravitation, same thing is called gravitational potential. When my marker falls from this point to this point, it is going from a higher potential to lower potential.
Yes, sir.
Is it clear?
Yes.
In heat, I have it as temperature. In fluid mechanics, I have it as pressure. All of them do the same job. Understood?
Yes, sir.
Or I can say all of them are the prime reason why that particular thing is happening that way. In the sense, why is the charge going from A to B? Why is it not going left side? You can say, you can, no, nothing to be. Stability comes when there is equilibrium. No?
Yes, sir.
Stability comes when there is equilibrium.
It always wants to lose energy.
Yeah, good. That is correct statement. Definitely. Okay. So it always wants to lose energy, therefore it always tries to go from higher potential to lower potential. Okay.
Yes, sir.
So what I'm trying to say here is, when we discuss of why is it going from A to B, if you leave energy aside, energy is anyways important for all the chapters. But if you keep energy aside and if you look at it, you can say it is because of electric field. But it is more easy to come in discuss in terms of potential, and it is also more easy and more conceptual also. Are you getting my point?
Yes, sir.
It is the ability of Earth which is taking the marker from top to bottom. Of course, there is a gravitational field, but can I say that the field effect will become main reason, or is it the ability of Earth? In these two, of course, both are the same and both have the same meaning and all. But I would rather say that the ability of Earth is the thing which is taking my marker down. Are you
Yes,
getting
sir.
my point? And that ability is nothing but potential.
Yes, sir.
Although all of them are interrelated, there's no doubt in that. Right?
Yes, sir.
So, in this situation, we are saying that VA is greater than VB. Right? Fine?
Yes.
VA is greater than VB. Therefore, the charge plus Q is going from A to B. Okay?
Yes, sir.
That means, remember, whenever I have a electric field, okay, whenever I have a electric field in this direction, and if I have 2 points A and B, okay, and electric field is from left to right, we will always have VA as greater than VB. Understood? Clear?
Yes, sir.
Coming back to this story, we are saying there is a change in potential, right?
Yes, sir.
Now, change in potential, change in physics is always final minus initial.
Hmm.
Therefore, it is going from A to B. So, this is my initial and that is my final.
Yes, sir.
That means over here, in place of delta V, I'll have a minus sign. What will my delta V be? VB minus V.
We'll have B minus C.
B minus. Is this clear?
Yes, sir.
So, I can also write this as VA minus V. If I
Yes,
take
sir.
the minus sign inside. And simply now I can write my VA minus VB is equal to E bar dot R bar. Correct?
If you take magnitude, you can subtract it with magnitude.
If we take magnitude, we can.
I mean, it doesn't matter how we subtract.
It doesn't matter if we subtract who.
I mean, like, there won't be any change if we want. Like, if we do VB minus V
Oh,
or
you're
VA.
saying this one, if we take modulus of it, then there is no problem in it, right?
Yes, sir.
The physics part of it tells me that I'm going from higher potential to lower potential when there is an electric field. That's why this is. Are you getting my point?
Yes, sir.
If I talk of numbers 50 is equal to 50, no problem. But if I look at the physics point of view, I am trying to show that I am going from higher minus lower on the LHS is equal to electric field dot product with the displacement.
Yes, sir.
Is it clear?
Yes, sir.
Fine.
Yes, sir.
The dot product is nothing but E bar mod A mod B cos theta.
Yes, sir.
A dot B is AB cos theta. I can write this as mod E bar mod R bar into cos theta. Here cos is 0 because both are parallel.
Yes, sir.
R bar is from left to right, E bar is from left to right. Angle between them is 0.
Yes, sir.
So in terms of magnitude way also I can write this as E is equal to VA minus VB divided by R.
Yes, sir.
And if I want to write it in terms of calculus way where I was here, right?
Hmm.
This delta is nothing but change, right? And if I make it infinite small change, that itself will become calculus.
Yes, sir.
If I want to write it in terms of calculus format, this same thing will become minus dV by dr. But here I have told you that I am taking it as R, I am not taking it dr. Because I took it as R because dr is only used in one particular position. Why should I write dr again and again every?
Yes, sir.
If it's an infinite small change, when I say calculus, I'm talking of infinite small changes.
Mm.
So in terms of calculus, I am talking of infinite small changes. Obviously, I'll bring the differential elements dr, dv, and so.
Then won't it be like VA initially the same, so there's small change in potential at B, so won't be write as DVB?
Repeat.
Sir, initially when we are displacing some, I mean, when it is getting displaced a DR, initially it is having like the same potential at A, but when you're displacing DR, it is becoming DVB, right? Won't we write DVB?
There is no such thing as dva, dvb. dv itself is vb minus va.
Yes, sir.
Simply, if I write this as this is only my dr bar. What is your dv? Vb minus va. Final minus c.
Yes, sir.
I did not write it as dr bar because the calculus only will use d. Everywhere else, I don't have to use calculus. I am saying everywhere else without my differential element, my signs will stand.
Yes, sir.
See, here I want it. This form is also used.
Yes, sir.
What I am trying to say from this particular thing is that if E is equal to minus dV by dr, that means I can say that electric field is slope of tangent, right? Negative of slope of tangent in V versus R graph.
Yes, sir.
Are you getting my point?
Yes, sir.
Okay, so what we are discussing over here has a lot of expressions. Story is the same. Story is very simple. Leave a charge, it will go by itself. Leave a charge in an electric field and it will go by itself. Right?
Yes, sir.
Wait. We still have stuff to do here.
Okay.
See, if you look at this particular part, we have written minus delta U is equal to minus of delta Q into V. Only from this also, if you see, delta U is equal to Q into delta V. Correct?
Yes, sir.
Yeah. Delta U is equal to Q into delta V. That means, what is delta V by the way? Final minus initial, VB minus VA, right?
Yes, sir.
And delta U is what again? UB minus U. So
Yes.
simply from here I can write potential energy of at B minus potential energy of at A can also be written as Q times of potential energy of
Minus.
potential at B minus potential at A.
Yes, sir.
Is this clear?
Yes, sir.
If suppose somebody gives you electric field and R, you can get this VA minus VB here, substitute it over there. You can get UB minus UA also.
Yes, sir.
Many things are here interrelated.
Yes, sir.
Are you getting my point?
Yes, sir.
Many things here are interrelated. If somebody gives you electric field and R, you can get the potential difference. Using that, you can get the charge, multiplied with charge, get change in potential energy, which also means that you are also getting work done out of it.
Mm.
Understood?
Yes, sir.
So, one point what we are trying to understand is when there is an electric field from left to right, the left point will be at higher potential, the right point will be at a lower potential. Correct?
Yes, sir.
If I am saying that VA is higher potential, VB is lower potential, that also means that UA is higher potential energy and UB is lower potential energy. Like you said, the system wants to lose energy.
Mm.
UB is low potential energy, UA is high potential.
Yes,
Correct?
sir. Yes, sir.
Clear? So,
Yes, sir.
so if I have to get a generalized perspective, there are a lot of things written on the board right now. If I want to write a generalized perspective of what are the majority things that I use, Story is simple. Electric field, put a charge, it will run away.
Yes, sir.
That's the only story. And out of it, we got work done is equal to charge into Q into negative of change in potential. Correct?
Yes, sir.
Fine.
Yes, sir.
Which can also be, we already know that it can be written as negative of change in potential. Fine.
Yes, sir.
Next, what we figured out is that the negative of change in potential can be written as, in terms of electric field, E bar dot R bar, or you can write it as E bar dot dr bar. Our wish. Fine.
Yes, sir.
In terms of scalar, we can write in calculus E is equal to minus dV by dr. This is also used in many questions.
Yes, sir.
Okay. And in this particular example, so these are all like writing it in terms of change. If I want to write it in terms of A and B, higher potential energy, lower potential energy, right?
Yes, sir.
So I will write UA minus UB is the lost energy.
Yes, sir.
You know UA is greater than UB because VA is greater than. So I can write this is only work done, and I can write this is only basically Q into VA minus VB. I can write it this way, right?
Yes, sir.
Next, this VA minus VB potential, I can simply write it as E into magnitude R. Is this clear?
Yes, sir. I don't know where to start from.
Yeah, you're right. Just Xerox. Whatever is there, we started it from here.
Yes, sir.
It is also slope of the one last thing I have to explain. See, if I have a uniform electric field, we said if I am going parallel to the electric field, higher potential, lower potential, we have figured that out, right?
Yes, sir.
Now I have a point P, I have a point Q, and let's take a point R also. Okay, and PQ is perpendicular to PR.
Work done at 0. 1.
From P to R, the electric field is in which direction? Horizontal direction.
Yes, sir.
If you remember one conceptual statement, the component of a vector in its perpendicular direction is 0.
Yes, sir.
The component of a vector in its perpendicular direction is 0.
Yes, sir.
If electric field is 0, that means dV by dr is 0.
Yes, sir.
Or we can say dV is 0.
Yes, sir.
When we say dV is 0, I can say V is constant.
Yes, sir.
Are you getting my point?
Yes, sir.
Electric field in the vertical direction is 0. Therefore, I can write Vp is equal to Vr. And anyways, from all these examples, I already know Vp is greater than Vq. Is this clear?
Sir, there'll be potential in between of P and R, but
There will not be a potential difference between P and R. If there is a potential difference and a displacement, you will have an electric field.
yes, sir.
But electric field is in the horizontal direction. The component of this electric field in the vertical direction should be 0. If electric field is 0, potential is constant.
Yes, sir. I understand.
So Vp will be equal to Vr because
Yes.
electric field in that direction is 0. In fact, this line itself you can call it as equipotential line, or you can also call it as equipotential surface depending on 3 dimension. If you have,
Yes, sir.
there is a sheet perpendicular to the board,
Mm.
right?
Yes, sir.
Or you can say it is equipotential line. Clear?
Yes.
Hi guys, I hope you enjoyed this session. If you think this video was useful, don't forget to like, share and subscribe to my channel. Also, I'll be waiting for your comments in the comment section. See you in the next video.